Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled NGC 1275 in the Perseus Cluster. So, what do we see here? Well, the image is showing us the Perseus Cluster of galaxies. So much of what you're seeing here are galaxies. And in fact, you can take a look at the brighter objects, and those will all have a little bit of an extended structure. How can we tell the difference? Well, a brighter object that is a star will have a diffraction pattern or a cross pattern going through that. So you can see some of those that stand out there. Some of them are bluer stars, some of them redder stars, but they have that distinct cross pattern going through them that identifies them as a point source of light rather than an extended source of light, which would be a galaxy. Now, among the galaxies, one stands out toward the center, and that is known as NGC 1275. It's also known as Perseus A, the brightest radio source in the constellation. And it is an example of an active galaxy. Now, active galaxies differ from an ordinary galaxy in a couple of ways. First of all, they tend to be brighter, giving off more energy than a typical galaxy, and they also emit different types of energy. And in fact, an active galaxy will emit far more of things like X-rays and radio waves on the opposite ends of the spectrum than you will ever get with a normal galaxy. That doesn't mean a normal galaxy doesn't emit some of these, but not to the extent of an active galaxy. Now, as we look at the center here, we see all sorts of structures from this galaxy, which is telling us that this galaxy, as an active galaxy, is being fed. Material is flowing into it, whether from other galaxies and stars flowing in toward that central black hole that all galaxies have. And as that goes in there, it spirals in toward the black hole, being heated up to extremely high temperatures. That's some of the ways that we get those very high energy X-rays, heating that material up to really high temperatures as it spirals into the black hole. Now, we can't get any energy out of a black hole like this. Once material crosses the event horizon, it's done, and we will never be able to get any information about it again. However, as it spirals in, it can give off material, and some material can escape before it reaches the event horizon, giving us some of those very long structures that we see. And at this distance, we're looking at structures that could be tens of thousands of light years long. So that is a really large size, a good fraction of the size of our own galaxy. Our Milky Way about 100,000 light years across, so some of these would fit about a fifth to a quarter of the way across our Milky Way, giving an idea of how big these tendrils of material that have come out have been. Now, these actually seem to persist and last, even though they should be gone by now. And that's because of all the galaxy collisions we kind of expect would eventually destroy these. So there are some ideas as to why this might occur. Why do these manage to survive? And it can tie into the galactic center and the magnetic fields that might be able to help hold these together for longer time frames than we would otherwise expect. So that was our picture of the day, titled NGC 1275 in the Perseus Cluster. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.